17 on our Unit 2 review. Okay, we're getting into, this is the first geometric proof. Okay, so when we're doing geometric proofs, remember, we're using things like definitions, postulates and theorems, and properties, like properties of equality and stuff. So when you see POE like this, that's a property of equality. Okay, so those are the things we use as our reasons. Now remember, whether it's a geometric or algebraic proof, that first statement and reason is your given. So in this one, we are actually given two different things. Do y'all see that? We are given that A and B are supplementary angles, and that angle B and angle C are supplementary angles. So B and C are supplementary angles is already typed for us. So that reason should also be given. So if you are given more than one thing, you'll have more than one line that says given. So this first blank one is going to be the one that was not written. So they wrote the B and C. So we need to write in A and B. So angle A and angle B are supplementary. I don't know why that red ink is appearing. I really don't get it. I'm just going to abbreviate SUP because it's just going to keep messing up as I write. All right, so angle A and B are supplementary. Angle B and C are supplementary. Those were both given pieces of information. Now, do not miss that last statement. What goes in the last statement? Down here. What always goes down here? What did we talk about the past 2 days? And actually, past 3 days, because when we did algebraic proofs, we talked about this as well. You always start with your given. What do you always end with? What you're trying to prove. So I know what, I don't even have to look in the middle. I know that this is supposed to end with angle A is congruent to angle C. You start with your given, you end with what you're proving. Now, the reason that you end with, that's going to vary. We don't automatically know that at the beginning. Okay, so now the only other blank here is a reason for lines 3 and 4. Okay, so remember, your reason is how did I get this from the previous information? So from that previous information, this given information up here, how did I get this? That angle, the measure of angle A plus the measure of angle B equals 180. How would I know that those add to 180? What did they tell me they are? Supplementary. What does supplementary mean? Supplementary means they add to 180. That is the definition of supplementary. So that is the reason I was able to write that they add to 180. You can write that twice. They didn't put a line there because that's the reason for both line 3 and 4. Since A and B are supplementary, the measure of angle A plus the measure of angle B equals 180. Since B and C are supplementary, the measure of angle B plus the measure of angle C equals 180. Then they have the rest filled in, but I'll just walk you through it. Since those both equal 180, they must equal each other. That's you could have said the transitive property here, or they said the substitution property, because since 180 is equal to this, you could substitute 180 for this. So their substitution or transitive property would work. And then because those are equal to each other and both of those have measure of angle B, if I wanted to drop the measure of angle B, since it's on both sides, since it's positive, to drop it, I would have to subtract it. So if I subtracted the measure of angle B from both sides, it would eliminate, and I'd have the measure of angle A is equal to the measure of angle C. So that was the subtraction property of equality. And then we go from measures are equal statement to a congruent statement. That's the definition of congruence. They actually wrote that out, but you could have just written definition of congruence. I'm actually going to put that. That is the definition of congruent. You can write the word congruent or do the symbol, however you want to do it. Okay, and again, here where they said substitution, you could have also used transitive. That would have been correct as well. All right. Let's flip to the last page then and look at these next couple of proofs. So number 18, they give us a picture this time, and it says, given that angle 1 and angle 2 are complementary, and they already wrote that. They have that. Oops. Hello. They already wrote that and told us that was the given information. Okay, and they already wrote what they're trying to prove down here. So those 3 lines that are the easiest to fill in are already filled in. Okay, so unfortunately that's not one of our questions. That's already plugged in for us. But that's all right. So let's look. 1 and 2 are complementary. What does complementary mean? Say that again, Evelyn. 90. They add to 90. If the angles are complementary, they add to 90. So isn't that what they wrote on the next line? The measure of angle 1 plus the measure of angle 2 equals 90. So they add to 90. The reason that they were able to write that is the definition of complementary. Okay, so we're told they're complementary. So we use the definition of complementary to write out the equation. So then they say, okay, if those are equal to 90, then I also know that angle 1 is congruent to angle 3, because you can see here, angle 1 is a vertical angle with angle 3, right? They're across from each other at the intersection of those 2 red lines. Okay, so angle 1 is congruent to angle 3 because they're vertical angles, and angle 4 is congruent to angle 2 for the same reason. Those are also vertical angles. So we've got 2 different sets of vertical angles marked congruent, and the reason is their vertical angles are congruent, or definition of vertical angles, however you want to put that. Now I can make I can say, okay, if those are congruent, I know that the measures are equal. So I go from the congruent statement to the equal measure statement using the definition of congruent. Okay, so for both of those. Then if I know those measure 1 and measure 3 are equal, and measure 2 and measure 4 are equal, in that statement that I wrote on line 2, I can replace 1 with 3, and I can replace 2 with 4. That's substitution. If things are equal, okay, which we wrote here in line 4 that they're equal, you can substitute them in for each other in other equations. So I use substitution. Well, now that I know the measure of angle 3 plus the measure of angle 4 is 90, I can say angle 3 and angle 4 are complementary. Again, that's the same reason I wrote up there. It's the definition of complementary. So when you're using definitions, notice you can go in both directions. So you can go from them being complementary to the equation. You can go from the equation to writing their complementary. Okay, so, and same thing with, we've done it with the definition of congruence too. We've gone from a congruent statement to an equality statement, and we've gone from an equality statement to a congruent statement. It works in both directions. All right, 19 says T is the midpoint midpoint of SU. So I'm going to label in my picture, if this is the midpoint between S and U, what do I know now about these two smaller segments created? What does midpoint tell us? What does midpoint mean? Midpoint means it's the middle, right? So if you're in the middle, isn't that the same distance from both ends? So what do I know about these two segments? They're the same length, which means congruent, right? So I can put the tick marks on my picture and I can write the statement. Okay, so ST is congruent to TU. And I just realized that is a typo here. Line 2, that's supposed to be a T, not a U. ST is congruent to TU. I know that because that's the definition of midpoint, which is what I was given. Still need to write my given. T is the midpoint. Abbreviate midpoint. Okay, so make sure you fix the typo. That's supposed to be ST is congruent to TU. Then they go from the congruent statement to the equality statement. That's definition of congruent. Then in the picture, do you see how ST is labeled 7x? And TU is labeled 3x plus 20? So they substitute. Okay, they replace ST with 7x. So that's substitution. Okay, now we're trying to solve for x. So how would I get the x's to the same side? How would I move this 3x over? It tells me right here. Subtraction, right? So if I subtract 3x to the other side, what's 7x minus 3x? What is that going to leave me with? 7 minus the 3. 4x. And the 3x would be gone. And so I'd just have 20. If you need to actually show the subtraction, if that helps you, show minus 3x on both sides. And the 3x cancels. So we're left with 4x equals 20. Now, how do we get rid of that 4 in front of the x? Divide, right? So that's where x equals 5 comes from. So our reason how we got from here to here was by dividing. It is the division property of equality. We feel okay about that one? So that mixed geometry and algebra proof. That put them together. All right, number 20 says OC is the bisector of angle AOB. Okay, so AOB, and trace it if you don't know what angle it is. That's this, A to O to B. So this big angle is bisected by OC. So what does bisect mean? Cut in half. So you can see they've already put the markings on here that these two angles are congruent because that is the definition right here. Those two angles are going to be equal measures. Okay, that is the definition of an angle bisector. That it creates two equal angles. Two angles of equal measure. Okay, what is that first reason supposed to be? What's always that first reason? Given. Yeah, they gave me that information. So I'm just going to write given there. And then I went from that given piece of information to knowing that those angles are equal based on the definition of angle bisector. Then using the definition of congruent, I'm going to go from an equality statement to a congruent statement. And that's what I'm trying to prove. Even if you didn't know that, what you're trying to prove should always be what you're writing down here, shouldn't it? So the measure of the angle is equal to the measure of the angle. I think that's actually another typo up here, that this is supposed to have a squiggle. That's supposed to be a congruent statement. You're supposed to go from the congruent statement to the equal measured statement. All right, last but not least, an algebraic proof. What is always the first reason again? Yeah, that is given. Okay, I've got to know that. And the last statement is always what you're trying to prove. So I'm given that 44 minus 2 times 3x plus 4 equals negative 18. Now I'm trying to solve for x here. Obviously, I want to get to x equals 9. So what am I going to do first? What's your first step in simplifying over here? How do I get rid of those parentheses? It tells us right here, the first reason. The distributive property. So I want to distribute, which is multiplying, but I need to use the right terminology, because the multiplication property means you're multiplying on both sides of the equation. Distribute means you're multiplying into the parentheses. So I'm going to take that negative 2 and multiply it. So the 44 in front doesn't change. Negative 2 times 3x would be negative 6x, and negative 2 times 4 would be negative 8. And then the right side, the negative 18, doesn't change. Now, how did they get from what we just wrote to negative 6x plus 36? Where did the 44 and the minus 8 go? They combined them, didn't they? They made it into 44 minus 8 is positive 36. Let's combine like terms, or maybe simplify. Then to get the negative 6x by itself, how did they move that 36 to the other side? What operation? If it's a plus 36, what's the opposite? That is the subtraction property of equality. And that's it. Y'all have a good lunch. Yeah, hang on. Let me stop this recording. That's okay.